Now that we have seen a few quite active devices, let's revisit the receiver architecture, the different kinds of receiver architectures possible for receiving RF signals. One essential component is the antenna that really picks up the RF signal from the air, and that received signal strength is going to be so weak that first and foremost we want a low noise amplifier to boost it up. Followed by that is what is introduced as an image reject filter, which we discussed when we looked at what a mixer does, essentially to have a pure shifted version of frequency translated version of the RF signal that is picked up by the antenna beyond the mixer, but shifted to a frequency called as the intermediate frequency. So essentially there is a local oscillator LO, and the IF frequency FIF is going to be FRF minus FLO, the local oscillator frequency. And this frequency being much lower, the requirements for digital sampling is going to be lower as well. That means it can be sampled at a lower sampling frequency. So the sampling frequency, even if you were to meet the Nyquist sampling criterion, which says that the sampling frequency must be twice the maximum frequency in the input signal, that can be done easily even with a slow rate analog to digital converter. And subsequent to that is the digital signal processing unit that can be used for digital demodulation. So this kind of architecture is what is called as a simple heterodyne receiver. And the fact that we have a mixer here is why it is called as a super heterodyne receiver, with introduction of an image reject filter. So another possible architecture is a direct conversion receiver where this intermediate frequency is set to be 0. That means the RF is directly converted to baseband, and in this case there is no need for an image reject filter, because the image frequency is technically not there, because the local oscillator is exactly the same as the RF frequency. So in a sense the image frequency is 0 Hertz, and that is not going to be picked up by the antenna anyway, and that need not be introduced here. An image reject filter need not be there. The output of the LNA can be directly connected to the mixer. The key thing is the local oscillator must be the same as the RF frequency. So omega LO is the same as the omega RF. So directly what we receive is the baseband signal that can be converted to digital form using the analog digital converter, and subsequent signal processing techniques can be applied. So for phase modulation schemes where information is included in the phase component of the signal itself, there are, in a receiver, especially in digital modulation schemes, if you want to receive such signals, it is useful to split the signals into what are called as in-phase and quadrature components, both as in-phase and quadrature components. And this in-phase and quadrature components is where the information is encoded into, with phase as being one of the parameters where the information is transmitted. And for such an architecture, the local oscillator frequency is the same, but you use two different versions of it. One directly connected to the RF input, the FRF that comes in here. You mix that directly with the output of the local oscillator. The second quadrature component is when you phase shift the local oscillator by 90 degrees, meaning that if this were to be a cosine signal, then after 90-degree shift it's going to be a sine signal, sinusoid. So you get an in phase, which is the cosine signal, and the quadrature component, which is the sine signal. Again mixing it up with the RF, the same RF being split into in phase and quadrature phase, and the two in phase and the quadrature components can be individually sampled using analog to digital converters, and subsequent signal processing can be done to obtain the information. So what we see next is what is called as a transceiver architecture, which means it has both a transmitter plus a receiver. So like what we discussed in the amplifier videos, A transmitter is going to have a power amplifier, whereas a receiver is going to have a low noise amplifier in the chain. So in essence, the signal as it flows into the system is going to be the receiver, and the part of the system where the signal flows out of the system is going to be the transmitter. And one unique component in a transceiver is this duplexer component, which essentially can be a circulator, the passive device that we saw as circulator, where the same antenna can be used for transmitting for both TX and RX. The same antenna can be used for both transmission and reception. In other words, whatever the antenna receives goes to the receive chain, and whatever the antenna, whatever the duplexer is fed as the input RF signal is going to go into the antenna. So the rest of the architecture for the receive chain is no different than, for example, the IF receiver, digital IF receiver that we have seen, with both the in phase and the quadrature phase components and then you got in the transmit chain, the digital to analog converters are used, essentially translating the low frequency signal through a suitable choice of local oscillator to a high frequency, but that is done in stages. That means it's done to the intermediate frequency first, omega IF first, and then the second level of mixing happens, where omega IF is converted to omega RF. So this is one kind of typical transceiver architecture that is very commonly used.